So today's lesson is looking at multiplying brackets. We're going to have a look at when we multiply two brackets, and then we're going to have a look at how we deal with multiplying three brackets in a row. It's really important that you've got a good idea about how to do the multiplication of brackets, because it is something that can be tested directly, but it's also something that can come up when you're working through a longer question. So you don't want to be making mistakes with your brackets and then losing marks for other things that you can do. Okay, so it's one of those important key skills. So starting out with two brackets. And this is our beloved FOIL. So in letter form, A plus B, C plus D. So it doesn't matter if we've got letters, if we've got numbers, if we've got pluses or minuses. When we've got two brackets, what we have to make sure is that everything is multiplied by everything else. We can't just multiply a few things. So a nice way to keep track of how to actually make sure that you have multiplied everybody is FOIL. So using a rainbow of colors, F in the FOIL stands for first. So we would do A times C. Our next is O, and O stands for outer. So plus A times D. The I is for inner, which is B times C. And the last one is a L for last, plus BD. So first, the first two in each bracket. Outer, the ones furthest away in the two brackets. Inner, the ones closest together, one from each bracket. And then last, the last one in each bracket. And each time we multiply. So AC plus AD plus BC plus BD would be our complete and final multiplication. And in this case, we don't have any like terms. So that would be our final answer. But generally when we're doing this with like numbers and letters, then we do end up with like terms and we can simplify. So running through one quick example here to show you what I mean by that, and then we'll do a few more examples just to make sure that you've got the rhythm of the FOIL. So if we had something like an x plus 1, x plus 5. So first, x times x, that gives us x squared. Outer, x times 5 plus 5x. Inner, 1 times x plus x. And last, 1 times 5 plus 5. And you see that in this case, we actually have two terms that have just an x in them. We have like terms. So we have an x squared term, two x terms, and a constant term. So our x squared term, there's nothing to simplify there. But 5x plus x we can simplify, plus 6x. And then our constant term is the only one that's just a number, so just plus 5. So very often we will be expanding brackets to make quadratics like this, and it's really important that you've got all three of those terms. You get all three of those terms by working through all four multiplications for those two brackets. So let's run through a couple different situations just to make sure we're all on the same page and everybody is happy with multiplying out two brackets. So we're going to do x minus 3, x plus 2. What happens when we expand this expression? So x times x is x squared. Outer, x times plus 2 gives us plus 2x. And this is why this one's a little bit special from the last one we did. We have a minus here. And we've got to make sure that that minus sticks with the number. So the minus must stick to the 3 in the same way that the plus sticks to the 2. So we would have minus 3 times x, which would give us minus 3x. And then we would have minus 3 times plus 2, which would give us minus 6. And again, we end up with 2 like terms. So we have an x squared plus 2x minus 3x lands us to minus x, and then minus 6. So x squared minus x minus 6 is the expanded form of x minus 3 times x plus 2. What is really, really cool is this works even if we add in more negatives. Let's say we have x minus 3, x minus 2. So very, very similar, but not quite the same. Let's see what the difference is when we get to that fully expanded form. So first, x times x, x squared. Outer, x times minus 2. That minus must stick to that 2. So minus 2x. Minus 3 times the x, minus 3x. Minus 3 times minus 2 gives us a plus 6, because we've got the same signs. And now see, we've got a very, very different term here as well, because we've got x squared, but now we've got minus 2x minus 3x. So we have minus 5x plus 6. So yes, we've got an x squared, same in both. We've got a 6, same in both. But that's it. We've got minus x minus here, and we've got minus 5x plus here. So it is so important that you keep track of your signs very carefully, because it is keeping track of those signs that's going to have a massive impact on your final answer. So even if we step it up inside the brackets, making things a little bit more interesting, let's say we have 2x plus 3, 3x minus 4. So now we've got numbers stuck to our x's, but this multiplication still stays exactly the same. We still work through all of those same steps. Okay, it's just that now we're going to multiply numbers as well as x's. So first, 2x times 3x. So our numbers would combine. 2 times 3 is 6, and our variable would combine. X times x is x squared. Outer, 2x times minus 4. So our numbers combine. 2 times minus 4 is minus 8. And our x, because we only have the one x from the 2. Inner, 3 times 3. And they're both positive, so plus 9. And again, an x. And then the same pattern for the last one. 3 times minus 4, so it gives us minus 12. We have our like term sitting there in the middle, so we have 6x squared. Minus 8 plus 9 would give us plus 1, so we don't bother writing the 1, because he's just implied when we write just the x. Minus 12, that didn't simplify. So 6x squared plus x minus 12 is the expanded form of 2x plus 3 times 3x minus 4. Are we happy so far? Okay, we have happy people. So we're going to look at another couple of ones, because there's another way of writing a multiplication of brackets. You see here, in each of these cases, we've had 2 different brackets, and we can see them plain as day as soon as we look at the question. Okay, but we can have the question written slightly differently. We can have this question written as x plus 3 squared. Now, what happens in this case? Is it x squared plus 9? Yeah, absolutely not. Never. Not going to happen. Please don't. That is breaking all of your exponent laws. Okay, x plus 3 all squared. So the same time that a squared equals a times a, x plus 3 all squared has to equal x plus 3 times x plus 3. So in this case, we need to give our two brackets. So they're exactly the same, because when we're squaring something, we're multiplying it by itself. But we've got to give those two brackets so that we can then FOIL. So x times x gives us x squared. X times 3 plus 3x. 3 times x plus 3x. 3 times 3 plus 9. So x squared plus 3 plus 3 is 6x plus 9. So you see, if you had broken those exponent laws and you just said x squared plus 9, you would have missed out that 6x entirely. So it's really important that when you're dealing with expanding brackets, when it looks like this and you've got that bracket squared, you must have bracket times a bracket, because it's the bracket that is squared, not just the x and the 3. So if we have 5 minus 2x squared, you already know. Now it's 5 minus 2x, the whole bracket multiplied by itself. So 5 minus 2x times 5 minus 2x. And then we FOIL. No shortcuts, no laziness when it comes to squaring brackets. 5 times 5 is 25. 5 times minus 2x, minus 10x. Minus 2x times 5, minus 10x. Minus 2x times minus 2x, minus times minus, plus 4x squared. So 25 minus 20x plus 4x squared. And that's our expanded form, but it's a little bit wonky, because normally, remember, we give our quadratics ax squared plus bx plus c. So because the x was on the right-hand side in the brackets, it's ended up on the right-hand side for the x squared at the end. But we can just rearrange. So we would take each term with its sign. So plus 4x squared, we would just rewrite that as 4x squared minus 20x. And then our 25, the hidden sign attached to that, is a plus 25. So now we have a quadratic that looks in a slightly more normal format from what it did on the line above. We have our standardized ax squared plus bx plus c. But it doesn't matter how complicated the bracket is. It doesn't matter how it's presented. If it's presented as two different brackets, or if it's presented as one bracket squared, you're still going to give your two brackets, and you're still going to work through first, outer, inner, last, in order to catch all of those multiplications in order to get your full expansion. So are you happy? Can we move on to what happens when you have three brackets that are being multiplied? You guys are quick on the keys. Okay, it looks like we are happy. So we shall move on to three brackets. So this is something that's new for 2020. So you won't come across it in past papers, but it will be coming up in your exam. So in this case, we would have something like x minus 3, x plus 2, x minus 1. So we've actually got three brackets, each with two terms inside, all multiplied together. And the thing is that we still got to make sure that we get every single multiplication as we work through that expansion. So what we do with these is we start with two brackets and we make our quadratic. And then we multiply by that third bracket. So we're going to do it in two different options, because we could decide that we want to start with the first two. Or we could decide that we want to start with the last two. So we're going to do this question both ways. So if we start with our orange root, we say we're going to multiply these two brackets, then the third one. So we would have x times x, x squared, outer, x times 2, plus 2x, inner, minus 3x, last, minus 6. But it stays in a bracket because we still have x minus 1. We haven't dealt with him yet, but we mustn't ignore him or lose track of him or forget about him. He's still a very important bracket. Okay, we've got like terms, so we want to simplify. X squared, 2 minus 3, minus x, minus 6. And then we still have our beautiful green x minus 1. Now, we've got to multiply everything in the orange bracket by everything in the green bracket. So we're going to start by the x. And that's how I keep track of them. So x times x squared is going to be x cubed. X times minus x squared. X times minus 6 minus 6x. Then we do exactly the same thing with the minus 1. Minus 1 times minus x squared, minus x squared. Minus 1 times minus x plus x. Minus 1 times minus 6 plus 6. So now we have covered all the possible multiplications that were existing in these three brackets, and we need to just collect like terms to simplify. So we only have one x cubed, so he sits there at the front. Minus x squared and minus x squared, so minus 2x squared. Minus 6x plus x, so minus 5x, and then only one number to sit at the end, plus 6. So now let's see the magic. If we decided, no, we don't want to start with the first two, we want to start with the last two. So in this case, our x minus 3 sits still, waiting for us to be done with the two brackets on the other side. X times x is x squared. X times minus 1 minus x. 2 times x plus 2x. 2 times minus 1 minus 2. X minus 3 doesn't get ignored. But first we're going to simplify our like terms hiding in the middle here. X squared minus x plus 2x plus x minus 2. And you see at this stage we're looking quite different to the other method. But the magic is coming, don't worry. X times each term. X times x squared, x cubed. X times x plus x squared. X times minus 2 minus 2x. Then the minus 3 times x squared minus 3x squared. Minus 3 times x minus 3x. Minus 3 times minus 2 plus 6. Oh, we got an x cubed and a 6, exactly the same as the other side. And let's see what happens when we simplify all the other terms. X cubed. X squared minus 3x squared gives us minus 2x squared. Minus 2x minus 3x gives us minus 5x. And our plus 6 sits at the end. And hey presto, we have x cubed minus 2x squared minus 5x plus 6. So it doesn't matter which two brackets you start with. You're going to end up with the same answer if you do them carefully and you get all of those multiplications. So whenever we're doing three brackets, we're going to take two brackets, get it foiled out to give us our quadratic, and then we're going to take that and multiply by everything in the other bracket. So we're going to work through another example, slightly more complicated one, with a slight twist on how we can keep track of things to give you another option. So if you like this one and it works for you, fantastic. Otherwise, here's another alternative. Let's say we've got x plus 4, 2x minus 1, x plus 3. Now, my general approach, unless there is something stupidly ugly, is to keep the first bracket as it is, because then I don't lose track of it. When I do my FOIL, there's not another one to add on to the end. Okay, so my preference, keep that one the same. Then we're going to work with the second two brackets. So 2x times x, 2x squared. 2x times 3 plus 6x. Minus 1 times x minus x. Minus 1 times 3 minus 3. Before we do anything else, x plus 4, combine like terms. 2x squared plus 5x minus 3. Now we've got to do x times everything plus 4 times everything. So we can just keep a track. If we're not so good at being organized and keeping track, we can also say x times 2x squared plus 5x minus 3 plus 4, 2x squared plus 5x minus 3. So it takes a little bit more time because we're writing that quadratic out twice, but it can be helpful in terms of keeping track of everything. Because now we can say x times 2x squared, 2x cubed. X times 5x plus 5x squared. X times minus 3 minus 3x. 4 times 2x squared plus 8x squared. 4 times 5x plus 20x. 4 times minus 3 minus 12. And again, now we've got a whole lot of like terms, so we're going to bring them together to simplify our expression. There's only one x cubed, so they sit at the front. Plus 5x squared plus 8x squared. 5 plus 8 is 13, so plus 13x squared. Minus 3x plus 20x. So 20 minus 3, it's the same as plus 17x. And there is only one constant, there is only one number, minus 12. So the full expansion of these three brackets gives us the cubic 2x cubed plus 13x squared plus 17x minus 12.